Okay, in this video we're going to start talking about bigger systems of equations. So in this case we're going to have three equations with three variables. And I have two systems of equations on the board, and just looking at them, stare at them for a minute, and if I told you to pick one and solve it, I have a feeling that most of you would pick the one on the right. And you should probably pick the one on the right. Because trying to figure out what numbers I should plug in for x, y, and z to make all three equations true is going to be kind of tricky over here because there's some complicated interrelationship between the three letters or the three variables. On the other hand, if I walk over here, at least the bottom equation is really simple. 3z is equal to 3. I should be able to solve this equation and say what z is. So z is some particular number. Seems like it's going to be the number 1. Once I know that z is 1, I can take that number for z and plug it into the equation above it, and I should be able to solve for y. And then at that point I'll know y and z, I'll be able to plug them into the top equation, and I'll be able to figure out what my x is. So if my system of equations is written in a form where when you line up the x's, y's, and z's, we have a triangle. This is what we mean by triangular form. Then it's going to be really easy to solve using just substitution. Solve the bottom equation and then substitute back from the bottom to the top. So I'll just finish solving this problem just to show you what I mean. Top equation, x minus 3y plus 2z is minus 3. Middle equation, y plus 2z is 5. Bottom equation, 3z equals 3. So if I take the bottom equation, which I think is the easiest one to solve, divide everything by 3, I get z is equal to 1. If I substitute that back into the previous equation, or the next equation up, we get y plus 2 times 1 is equal to 5. Y plus 2 is 5. Subtract 2 from both sides, and we get y is equal to 3. Take both of these answers and plug them into the other equation. And we get x minus 3 times 3 plus 2 times 1 is negative 3. X minus 9 plus 2 is negative 3. That's a negative 7. So if I add 7 to both sides, we get x is equal to 4. So just like when we're solving a system of equations with two variables, we need a value of each variable to come up with an answer. So in this case, I would say x is 4, y is 3, z is 1. Or instead of writing it as a point, because it's not just two numbers, we'll write it as a triple. And again, we'll stick with alphabetical order. X, y, z will be a triple, and it'll be 4, 3, 1. Okay, so again, keep in mind what the solution of a system of equations is going to look like. It's going to look like a number that you can plug in for each variable so that each of the equations is true at the same time. So I don't want to plug in certain values of x to make the top one true and other values of x to make the middle one true. I want to find the same x, y, and z that makes all three equations true, or however many we happen to have. Okay, so if we get lucky and we start with a system of equations that's already in triangular form, it's in this nice array where we only have one variable in one row, and two variables in the next row, three variables in the next row, then we should be able to solve pretty simply. The idea is, if I have a more complicated problem, there's some way to rewrite a complicated problem into triangular form. And that's something called Gaussian elimination. And so it's really closely related to the elimination we've already talked about. But I'm going to leave it there for now. Just the moral of this story is, given a complicated problem, our strategy is going to be to try and rewrite it as a simpler problem, because once it's a simpler problem, then we should have some straightforward way to solve it. And you just start with the easiest equation and work your way up.